All right, welcome to Lesson 3.1, Watch and Write, representing proportional relationships. Our objective for today is I can identify proportionality in a table, graph, and equation. So we're going to start looking at proportionality, and we're going to start with a table. So here we have a table, and we're going to find the constant of proportionality, which is the thing that we multiply by. We multiply our hours by something to get how much we're getting paid. It's also known as the unit rate. So constant proportionality can also be called the unit rate. How much for a single unit? To find our constant proportionality, we're going to look at our number pairs here. 1 and 17, 2 and 34, 5 and 85, and 7 and 119. Now I want to know what the unit rate is, which means I need to have a 1 on bottom. But do I want $1 or do I want 1 hour? The key here is that we usually, if we have time, we want time to be on bottom. So I'm going to put hours on bottom, which means hours are our x and pay is our y. And we always do x divided by y. Oh, excuse me. I did that backwards. We always do y divided by x. Pardon me. All right, so I'm going to start with this number pair. I have my y is 17. And don't forget, just because it's set up with x on top and y on bottom in the table, when we set up our proportions here, we want to make sure that y is on top and x is on bottom. So I have 17 on top and 1 on bottom. I don't have to do anything to 1 to turn it into 1, which means that I'm going to keep the top the same, 17. So here is the constant proportionality for the first one, 17 over 1. That's the unit rate. Let's see if we have the same unit rate for each of our number sets here. So our next one, our y value is 34, and our x value is 2. And I want to get it into 1. I want to know how much for 1 hour, 1 unit. To turn 2 into 1, I divide by 2. So I do 34 divided by 2. And I'm going to use a calculator for that because I don't know it off the top of my head. So I'm going to do 34 divided by 2 equals 17. So far, so good. We have the same unit rate. So for the next one, we have 85 and 5. And we want a 1 on bottom. To turn 5 into 1, I just divide by 5. Which means I also have to do 85 divided by 5. Grab my handy-dandy calculator. 85 divided by 5 equals 17. So far we have the same unit rate, which is good. Means it might be proportional. Last one, we have $119 for 7 hours of work. I want to turn it into 1 hour of work. How much is this person getting paid for 1 hour? 7 divided by 7 gives me 1. Remember, anytime you want to divide a number to turn it into 1, you divide it by itself. 7 divided by 7, 5 divided by 5, 2 divided by 2. If I divide the bottom by 7, I also have to divide the top by 7. So 119 divided by 7, 119 divided by 7, 17. Magic. Because we got the same unit rate every time, this is proportional, and the constant of proportionality is right here, 17 divided by 1. Or we could also write this as just 17. 17 over 1, any fraction where 1 is on the bottom is just represented by the top number. Cool. So our constant of proportionality is 17. Now, how do we find the constant of proportionality from a graph? Here we have a graph that shows us the total cost for games. Now, there are some blanks here. which means we're going to have to mentally fill those in. It looks like it's counting by 2s, which means that each blank in between must be worth 1. So it would be 1, 2, 3, 4, 5, etc. Here we're counting by 10s, which with each blank in between, so half of 10, or halfway between 10 and 0 is going to be 5, so this must be 5, 10, 15, 20. So it's counting by 5s for each tick mark there. Now, if you have a graph, the easiest way to find the constant proportionality is to make a table. Now, I'm going to label our table before we do anything else. If you remember from previous years, the x-axis is the horizontal one, and the y-axis is the vertical one. So games are already labeled as x, so we don't have to guess, which means y is cost. Now, it gives us 4 dots here, so I'm going to use those points. Here's my first point, and it connects here to 1 game and $10. So there's my first point. My second point connects to 2 games and $15. My next point is 3 games $20. And lastly, we have 4 games for $25. Now, earlier we did y divided by x. We're going to do the same thing, y divided by x with each point. So let's start with our first one here. We have 10 is y, and I'm double checking here before I fill it in. Just because it's on top doesn't mean it should be in our fraction here, or our proportion. So we do 10 divided by 1, and I want to turn it into 1. I don't have to do anything to 1 to turn it into 1, which means 10 just stays 10. So there's our unit rate. $10 for 1 game. Let's look at our next one. We have $15 for 2 games. To turn 2 into 1, I need to divide by 2. To turn 15 into something, I need to also divide by 2. Let's grab our calculator. 15 divided by 2, 7.5. Interesting, we got a different number. All right, let's look at the next one. We have $20 for 3 games. I want to turn it into 1 game. I have to divide by 3, which means I have to do 20 divided by 3. Handy dandy calculator, 20 divided by 3, $6.66. And this is going to go repeat forever. Notice, different number on top every time. All right, let's do our last one. We have $25 for 4 games. Want to turn it into 1 game. I'm going to divide by 4. 25 divided by 4 gives me 6.25. Now, we have different unit rates every time. So what we would say is that this is not proportional as far as we know. We haven't talked about proportionality in this way yet. Technically, this is proportional. We're going to get there when we start talking about linear equations. We're not there yet. So this is a not proportional relationship. There is no constant of proportionality, no k value. Because this doesn't go through 0, and we've got different unit rates every time. There's no constant. There's nothing showing up over and over again like there was up here. All right, let's look at our base equation really quickly. We have y equals kx. We talked about this last year. You might be somewhat familiar with it. K is our constant of proportionality. This is what we multiply our x by to get our y value. This is what we multiply our hours by to get our pay. In this case, it would be 17. 17 times hours tells you how much money you're making. Our y is what we call our dependent variable. And our x is our independent. What happens to y depends on what we do to x. If I work for 5 hours, for example, we're going to multiply 5 times 17, our constant proportionality, to get $85. 17 times 5 equals 85. So when you write equations, this is the form we're going to use for now. All right, last thing, let's look at it all together. Here we have a graph of moon weight in pounds over here, and then we have earth weight in pounds on the bottom. This is our x, and this is our y. So moon is on our y-axis, earth is on our x-axis. So we're going to fill in our table, find our constant proportionality, and then use that to write an equation. So we already have our points. Let's look at our first point here. 6 earth pounds is equal to, between 0 and 2 is 1, is equal to 1 moon pound. Here we have 12 earth pounds is equal to 2 moon pounds. Here we have 18 earth pounds is equal to, between 2 and 4 is 3 moon pounds. And lastly, we have 30 earth pounds to 5 moon pounds. So we used our graph to fill in our table. So this information and this information are the same, represented in different ways. Now we need to do our y value divided by our x value to get our constant proportionality, assuming it's proportional. So let's go ahead and do our y value 1 divided by 6. Now to turn, in this case, I don't actually want to turn this one into anything. So I'm going to go ahead and leave it blank. I know we've been talking about turning it into unit rate. I don't want to turn it into a unit rate because that means I have to divide 1 divided by 6, which is going to give me a decimal. And if I can avoid decimals in my fractions, I'm going to. Here I'm going to do 2 and 12, but I'm going to see, can I turn it into 1/6? I know that 12 divided by 2 gives me 1/6, so it's 2 divided by 2. Well, that's 1. Okay, so far so good. If I can turn this into this, we're good. Let's look at the next one. We have 3 and 18. Can I turn 3/18 into 1/6? 18 divided by 3 gives me 6. 3 divided by 3 gives me 1. This is a good sign. Lastly, we have 5 and 30. And I want to see if I can turn this last one into 6. 30 divided by 5 equals 6. 5 divided by 5 equals 1. Here's our constant proportionality, 1/6. Because this is the number that shows up there, this is our constant proportionality, which goes here. Y equals 1/6x. So the earth weight times 1/6 will give us the moon's weight. All right, move on to practice. Let me know if you have questions.